Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. In this video, we are going to discuss about one more important solution technique, that is the variational method. So, what is the variational method? Already I told you in time independent perturbation theory questions, previous videos we are discussing in the previous videos how the questions are coming from the time independent perturbation theory. What are the major importance of the time independent perturbation theory? Those questions we discussed. In two questions I am giving. One is non-degenerate time independent perturbation theory. Another one is a degenerate time independent perturbation theory questions we are discussing. I am uploading in that video. In this class, we are going to discuss the next subsequent variational method is approximation method is variational method. One method does not solve exactly Hamiltonian problems. So, then we are coming into the variational method used to solve the approximation solutions of the Hamiltonian. Clear? So, this question was asked in CSIR June 2017. The regularly people are asking the questions in our CSIR gate examination. Now, you have to see what is that. Using the trial wave function they are giving, first the trial wave function they are giving. CSIR June 2017 this question was asked. The trial wave function, this is a trial function only. The trial wave function is equal to, what is the trial wave function? A into a square minus x square, when it will be exist minus a is less than x is plus a, otherwise 0. This is going to become as a 0. Otherwise, you are going to take it as a 0. This is the trial wave function. So, find the ground state energy of one dimensional linear harmonic oscillator. It is a one dimensional linear harmonic oscillator, one dimensional, right, one dimensional linear harmonic oscillator. So, the one dimensional linear harmonic oscillator means the potential energy, you know that V of x is equal to 1 by 2 m omega square x square. This is the potential energy. How the waveform is oscillating? The waveform is oscillating like this in the parabolic shape. That waveform is oscillating. This is 1 by 2 m omega square x square. This is the which one it is? A linear harmonic oscillator. Now, we need to calculate to find the ground state energy, the ground state energy by using a variational method. We need to follow the 4 steps. So, what are the 4 steps? Once you have to see. First, the first step is to make a trial solution, So, make a trial solution or guess a trial solution. Already the trial solution they are given. The trial solution is equal to a square minus x square. A square minus x square, when it is existing, minus a is less than x is less than plus a, correct? Now, it is not normalized because we need to calculate the normalization condition we have to calculate. It is not normalized. How we able to calculate the normalization constant? By using the normalization condition. What is your normalization condition? Your normalization condition is integral minus infinite to plus infinite. So, your limits are minus a to plus a. So, so trial wave function, your trial wave function conjugate into your trial wave function into with respect to x axis. That is why only I have to take it as a x. Now, you have to substitute here integral minus a to plus a. So, psi conjugate into psi a square into a square minus x square whole square into dx is equal to 1. So, now you have to simplify this. How you able to simplify? A square you have to take outside, integral minus a to plus a. a square minus x square is equal to a to the power of 4 plus x to the power of 4 minus 2 a square x square into dx, which is equal to 1. Now, one integral will become as a 3 integrals. So, therefore, a square into integral minus a2 plus a to the power of 4 into dx, integral minus a2 plus a x to the power of 4 into dx minus 2a square into integral x square minus a2 plus a integral x square into dx, which is equal to 1. We have to write it is. So, therefore, a square into integral a to the power of 4, you have to take the common outside. So, a square you have to write it is integral x. So, you have to take it as a minus a plus x to the power of 4 is equal to x to the power of 5 by 5 minus a plus a minus 2a square into x square means x cube is divided by 3 minus a plus a, you have to take it as a equal to 1. Now, a square into, so a plus a minus of minus plus a 2a to the power of 5. So, plus how much you are going to get here? So, 1 by 5 into, so 2a to the power of 5 minus 2a square into, here also 2 by 3 into 2a cube we have to take, which is equal to 1. Now, you have to simplify, you calculate the a value, how much you are going to get. A is equal to root 15 is divided by 16 if a to the power of 5, you are going to get. This is the normalization condition. Which condition it is? This condition you have to take it as a normalization condition. Based on that condition, you have to write it is, so that is what you have to write, your wave function you have to write. Now, your wave function psi is equal to a 15 is divided by 16 a to the power of 5 into a square minus x square. This function is existing. When it is existing, minus a is less than x is less than plus a, that time it is existing. This is the trial wave function. If it is not normalized, we are normalizing. This is the first step. Clear? So, after getting the first step, we need to take it as a step 2. So, what is your step 2? Your step 2 is to find the Hamiltonian. So, this Hamiltonian, it will give the energy value. So, now to find the Hamiltonian, the expectation value of the Hamiltonian is equal to the expectation value of the kinetic energy, the expectation value of the potential energy, which is equal to the expectation value of Hamiltonian. That expectation value of Hamiltonian, it will give the energy in terms of our parameter. Our parameter, what is our parameter? Our parameter is A. So, in terms of A, you are going to get it, so the energy value. First, we need to calculate the expectation value of kinetic energy, we need to calculate. So, what is the kinetic energy operator? You know that the expectation value of kinetic energy is equal to integral minus a2 plus a, your psi conjugate into the kinetic energy operator into psi into dx, which is equal to psi into dx. This is the expectation value. Integral minus a2 plus a, your psi conjugate is equal to root 15 is divided by 16 a to the power of 5. Your kinetic energy operator is equal to minus h cut square by 2m into dou square by dou x square, dou square by dou x square. Your psi is equal to, you have to take it as a, here one more thing is there, our wave function is a square minus x square also existing. So, your kinetic energy minus h cut square is divided by 2m. So, dou square by dou x square into, we have to write it is a square root of 15 by 16 a to the power of 5. So, into a square minus x square into dx, you have to calculate that one. How you able to calculate? 15 a to the power of 15 by 16 a to the power of 5, 15 by 16 a to the power of 5, you are going to get it. Integral minus a to plus a square minus x square. So that constant also you have to take. So minus h cut square is divided by 2m also you have to take outside. So therefore what is going to happen, you have to see dou square by dou x square is equal to, you are going to get it as a minus 2 into dx, you are going to get it. So minus 2 into dx. So again you have to take minus 2 also this side, right. So minus into minus plus 2 into h cut square is divided by 2m, 15 is divided by 16 a to the power of 5, integral minus a to plus a square minus x square into dx, a square minus x square into dx you have to take here. So what is going to happen, you have to simplify, you are going to get it as a 5 by 4 h cut square into 5 by 4 h cut square is divided by 5 by 4 h cut square is divided by m a square, you are going to get. This is the expectation value of kinetic energy. Now we need to calculate the expectation value of potential energy, we need to calculate. So what is the expectation value of potential energy? Minus a to plus a, minus a to plus a, psi conjugate into the potential energy into psi into dx. So therefore integral minus a to plus a, what is your psi conjugate? Your psi conjugate is equal to root 15 is divided by 16 a to the power of 5 a square minus x square into your potential energy is equal to 1 by 2 m omega square x square, 1 by 2 m omega square x square. Again you have to take, so root 15 is divided by 16 a to the power of 5 a square minus x square into dx you have to take. This is the potential energy. So what are the constant terms, you have to take 1 by 2 m omega square you have to take outside. So 15 is divided by 16 a to the power of 5 also you have to bring outside. So integral minus a to plus a, you have to take a square minus x square into, be able to calculate as a, which one you have to write, a square minus x square into x square, again a square minus x square also is there, again a square minus x square into dx. So therefore what we have to write, it is 1 by 2 m omega square into 15 is divided by 16 a to the power of 5, my integral minus infinite to plus infinite x square into a square minus x square whole square into dx. Now you have to multiply, you have to take the square this one. So what will happen, you have to take the square and you have to multiply with x square and integrate it. So you will get it and substitute the limits, you are going to get how much, m omega square a square is divided by 14, you are going to get it, m omega square a square is divided by 14. So therefore our expectation value of Hamiltonian is equal to, our expectation value of Hamiltonian is equal to the expectation value of V, K and expectation value of kinetic energy plus potential energy. So what is the expectation value of kinetic energy? 5 by 4 into h cut square is divided by m a square. This is the expectation value of kinetic energy. What is the expectation value of potential energy? The expectation value of potential energy, m omega square a square is divided by 14, which is equal to energy, you are going to get it. So this is the step 2. So while calculating the energy, what we have to do? So we are going for the step 3. We are minimizing energy. So the how we have to minimizing energy, with which parameter? Only one parameter is variable. So that's why dou E by dou A is equal to 0. So what is the dou E by dou A is equal to 0 minus 2 into 5 h cut square is divided by 4m A cube. So plus m omega square A is divided by 14. So m omega square is divided by 14 into 2. So 14 to 1 ja 2 7, which is equal to 0. So now you have to cross multiply, you able to get it a to the power of 4 you are going to get 2 1 ja, so 2 2 ja you are going to get. So how much you are going to get? So a to the power of 4 is equal to 35 is divided by 2. So a to the power of 4 is equal to 35 is divided by 2. H cut square is divided by, which one you have to get it? H cut square is divided by m square omega square you are going to get it. Clear? Now a square is equal to square root of 35 is divided by 2 into h cut by m omega. So this is the a value or a square, because in terms of a square is there. So that's why I have to calculate the a square value. Now this value you have to substitute in that energy value. You are going to get it as a exact energy, ground state, upper bound state value you are going to get it. So therefore step 4, what is your step 4? So substitute a square value, substitute a square value in equation number. So in step 2, that is the energy. So energy value you have to substitute. So therefore E is equal to, what is the E value you have to know? 5 by 4 into h cut square is divided by m a square. So m into a square is equal to, what is that value? So 35 by 2 whole to the power of 1 by 2, root 35 by 2 whole to the power of 1 by 2 into, so which one we have to write? It is h cut is divided by m omega. H cut is divided by m omega whole square you have to take. This is the a square value, not square. So a square only they are giving. Plus, so what is the potential energy? M omega square is divided by 14. Your a square is equal to root 35 by 2 into, so h cut is divided by m omega. So now m get cancel, 1 omega get cancel, m get cancel, 1 h get cancel. So therefore you have to take the common. So which one you have to take the common? H cut omega by 2 you have to take the common. So 5 by 2 you are going to get it 5 by 2. So into square root of 2 by 35 you are going to get it as a denominator by denominator. You are going to get it as a 2 by 35 plus, so you have to take it as a, how much you are going to take? So 1 2 is get cancel here. So h cut is divided by m omega, 1 by 7 it will come. So this is into the square root of, how much you are going to get? So the square root of, so 35 is divided by 2 you are going to get. So now you have to take these roots inside. These roots you have to take inside. H cut omega is divided by 2. So the root, so 5 you are going to 25 into 2 is divided by 4 into 35 plus, you have to take this one inside. 35 is divided by 49 into 2. So now you have to cancel it. 2 1 ja, 2 2 ja, 5 5 ja, 5 7 ja you have to take. 5 5 ja, 5 7 5 ja, 7 7 ja, and you have to calculate. So what will happen? You have to see that energy value E is equal to A is equal to h cut omega is divided by 2 into, so root, you are going to take it as a 5 by 14, root 5 by 14, so plus root 5 by 14 you are going to get it. So root 5 by 14, root 5 by 14 is equal to h cut omega by 2 into 2 root 5 by 14, root 5 by 14. So 2 2 get cancelled, therefore h cut omega into root 5 by 14. You are going to get it, this is the energy value corresponding to your trial wave function, clear. So now you have to check your answer. So what is your answer? Once you have to see your answer is equal to, so what is the your answer? So option B is correct, root 5 by 14, so h cut omega. So like that you have to do in your competitive examination. This is very, very important, clear. So this is the method to solve the variational method. First 4 steps are there. The first step, you have to make a trial solution corresponding to your entity or institution. So whether it may be linear harmonic oscillator, you have to take one. Already the solution they are giving, trial solution they are giving. First you have to see whether it may be normalized or not. If it is not normalized, you have to use the normalization condition and apply the normalization condition formula, you go for that. So next step 2 is you are going to take it as a step 2, find the expectation value of h. So here expectation value of h directly we are unable to calculate because h is not given here. So that's why the expectation value of h is equal to that average expectation value of kinetic energy, the expectation value of potential energy. Now again you have to minimize this according to the, so according to what is our is obviously is less than the expectation value of energy. So when it will be equal, so you are minimize that energy. So that minimize the energy corresponding to the operator parameter a square. So we have to do this, you are going to get it as a square value. In the step 4 you have to substitute the a square in that step 2, you are going to get the ground state energy corresponding to your trial solution. This is the method to solve the variational method. Only 4 methods are there to solve the system. So these methods you have to follow, clear. We started the CSIR and GATE physics coaching we started. If you really likes my teaching, if you really understandable my teaching style, so it is syncing, you have to download my app. Our app is Quantum Online Academy app. So once you have to download my app, after downloading my app, courses will display like this: CSIR and GATE physics, JL physics and DL physics course will appear. So almost these 4 papers recorded classes are available right now. If you want to take the individual paper also, you have to take the individual paper. If you want to take all, you have to call me and you have to negotiate me. Be serious, then only you have to take the course. Otherwise without practicing, without understanding, without liking the teacher, we unable to success all these competitive examination, because it is not 1 day 2 day journey. Maybe 1 year you have to keep to study the physics subject. So maybe I need to take the time to complete the syllabus 1 year. So that's why 2 years validity I am giving for the CSIR and GATE course. Once you want to take the course, 2 years validity will be there, clear. So thank you so much. Please share and subscribe our YouTube channel. It is very, very important. So you have to inform to your physics friends who are in the physics fraternity. Thank you so much. We will upload each and every topic in our YouTube channel. So listen and enjoy through YouTube channel also. Thank you so much.